everyone, welcome to our Staad Foundation tutorial. We're going to analyze our foundation of our frame structure. We have to open our frame structure, analyze it, and then import it to Staad Foundation. So here our structure frame. So we need to design the foundation. But before we will export this to Staad Foundation, you need to analyze first your frame. Run analysis. Let's just close this one. Then export it to our foundation. In the right side upper part of your screen, you will find a foundation icon. Click it. So here are the load cases for our structure frame we also utilize in our foundation. So this is the radio button. Use all support. So all support is to be designed. We will include all our cases. So let's include all. You see it is populated below. Those are our selected load cases to be imported to our Staad. So run Staad Foundation. Now our Staad Foundation application is being opened. So while we wait, you can check my videos. We have also a tutorial for Staad Pro. Don't forget to subscribe. Share the love. Also comment. So here in geometry, let's enlarge. You see, this is our foundations of our frame. So let's start with our project info. On the left side, just click there, expand this one, general information, project ID F01, that would be our project ID, project title foundation 01, then our site location, bill. So also here below client, then engineer's description, the designer, supervisor. So let's go to foundation plan. So here, this is our column position. The coordinates were already given. So column dimension, you could also say we have rectangular 0.4 by 0.4. You may wonder why it is given 0.4. It is our column design in our frame. So load factors, this is also features that you can utilize if you want to create new load. You will add loads, mud foundations, soil bearing capacity factors, and many others. Just go through to your application and just see what are the items that are listed in here. And after that, let's skip to job setup. So here, let's do create new job. So here, let's have our job name. So foundation 1. Remember, you cannot create a new job without job name. So listed support, leave it be. Now this is our available load cases. So let's just carry it over for our selected load cases to be analyzed. So click here, So everything like now, proceed to create job. On the left side, your main navigator will change. Isolated voting job, click it. Then we have design parameters. So let's have our design parameters. Insert our design parameters so we can analyze our foundation. So let us go to first item, concrete and rebar. So you would see that all the units here is in English. Let's change to SI. This is kilonewton per cubic meter. Unit weight of the concrete 25. So minimum bar spacing, I prepare mm. So that is minimum bar spacing is 100. Then maximum bar spacing, my unit is still mm. I would say 300. Strength of concrete, megapascal. We will have 20.7 megapascal. That is 3000 psi. Then the unit also. Megapascal. That is around 416 megapascal. That is grade 60. Then maximum bar size 8. Set default. Just leave it no. If you like to make it as a default, you can assign yes. Cover and soil. So bottom clear cover, I use mm. So that is 75. That is typically 3 inches. Now we will assign the unit weight of the soil. Kilonewton per cubic meter. There. Then let's have a value of 17.62. You can find your unit weight of soil on soil investigation. Soil bearing capacity, megapascal. Shall we say 120? Depth of soil above the footing. So I would assign 2. That is in meter. Surcharge of loading, kilopascal. Say 18. Undrained shear strength, never mind. So that's all for our cover and soil item. Let's go to footing geometry. Minimum length, meter. Let's have 2 meters. Here also in meter. That is minimum weight 2. Thickness still in meter. Minimum is 0.25. That is in meter. Maximum length meter is, shall we say, 4 meters. Also maximum weight meter, let's just put 4. So it is typically a square footing. maximum thickness in meter. So let's have this 0.35. Plan dimension in mm. Now let's have meter 0.05, that is 2 inches 50 mm. Meter 0.05, that is thickness increment. Offset, we will not offset our column. It should be located in our center of our foundation. So after that, let's go to sliding and overturning. Then factor of safety against sliding, like 1.5. We feel that our site is very safe from sliding. Factor of safety against overturning, our building is very low, so let's have 1.2. Then that is very much of all your datas for the parameters. So let's proceed to designing of our foundations. So finally we will proceed to our designing. So click here, design. A pop-up, say do you want to analyze or design? Yes. On our result, we notice that our structure is almost pure uplift, so it needs double checking on earthquake and wind load. So hope you learned something. Please subscribe, comment, and like. Bye.